Welcome back, aliens. My name is Navin Reddy, and in this video, we'll talk about ADT, which is Abstract Data Type. Now, before we move towards ADT, let's talk about data here. Of course, in the previous video, when we talked about what are data structures, we have talked about data. And we also mentioned that in the software industry, everything is about data. So whatever you do, you're doing it for data, right? Now, with this data, basically you get the data from the user, you process data, you also give the output to the user, or maybe you want to store this data in the database for the permanent storage. But the thing is, it's all about data. And whenever we use any language, doesn't matter which language you use, what you do is you store that data in your code somewhere. And to store that data, we use something called a variable. Now, imagine variable as a box and you are keeping your data inside that box. The problem is every box need to have a type. Of course, there are languages which are dynamically typed language where you don't actually mention the type for the variable, but in general, this box will have a type. So that means if you want to store the data, you need a box, which is your variable, and this variable also needs a type to it, or this box needs a type to it. Now, example, let's say if you want to store a number, so we can use something called an integer. Or if you have any other point values, you can also use float or double. Now, it depends upon the languages, how they work. But in most of the languages, we have something in common. We have integer for the normal numbers. We have a float for the point values. And what if you want to store a text? That's why we have string. And in few languages, we don't have all these types. We have limited types. And in other languages, we have many, but that doesn't matter, right? In general, we'll be having a variable and a type to it. Now, all these types are called data types, and they are system defined data types. Or you can also call them as primitive types, is because it's there in the language itself. You can directly use them. But sometimes you want to use some complex data type. And we can create that with the help of some other concepts. Example, let's say if you want to represent a human, or if you want to represent a phone. Now, I love phones, so I'll be using that example. So if we talk about this phone here, now this phone will have a name to it, right? So it will have a name, it will have a brand. Of course, name is model number, then brand, then the configuration, the amount of CPU, RAM, all this are your data, right? So if you want to represent any physical thing in the virtual world, we use objects there, right? Now, in some languages which are object-oriented programming, we do that with the help of objects. Example, in C, we use something called structures. So we can define a structure name, let's say phone, and inside that you can specify what are the properties there. In the same way, in the object-oriented languages, we use something called class. In this class, you create different variables with primitive type, and then the box itself, or the class itself, is your complex data type, or you can say user-defined data type. User-defined because system is not giving you, we are defining our own type, right? So that's about data and data types. But let's say if you want to store a bunch of data, how will you work with that? And when it comes to data structure, how will you store this data in a proper way? See, what happens is when you talk about primitive types as well, every type will have a way to store data. Of course, that's why we are getting them, right? So example, if you are creating a variable called num, now let's say this num is of type integer, and then you are storing a value to it. Now with this variable num, you can perform operations as well. Now what are the options you can do with integer? You can add two values, you can subtract two values, you can divide, multiply. So you can perform those operations on the number. But let's say you have a string there. Now with string, of course, you will not be adding to string. That doesn't make sense, right? Why you will add two names, let's say Naveen and Kiran, you will get a new name. Okay, a lot of parents are doing that for their kids, but that's not the idea here, right? We can't add string. We cannot subtract strings. But yes, with string, you can do something else. Maybe you want to see the size of a string. Maybe you want to concatenate two strings. Maybe you want to cut two strings. So string has different operations. In the same way, if you are creating your own type, this will have data, of course, but also you have to mention the operations which you're going to perform. So we have two things, right? We have data and we have operations. Now let's say in data structures, you want to store a bunch of data, as we mentioned, and you want to store, so there's a concept of array. So if you have multiple data, instead of showing them in multiple variables, let's say you have 5 numbers, 2, 6, 12, 21, and so on. Now, if you have all these values, you basically store that in 5 different variables. Or you can create a single array and you can store all the values there. The advantage would be you just have to use one variable name there. So instead of saying A, B, C, D, E, you can simply say nums. You can use any variable doesn't matter. So what's important is you can use array here. Now when we use array, we are not basically using a primitive type here. We are creating our own type here, own data type, which is an array. Now in this array, basically you should be also able to perform some operation. Example, let's say what if you want to read some value, you want to fetch a particular element, you want to search the array, maybe you want to add an element, maybe you want to delete an element. So this operation should be possible on that type. So in the concept way, when you have a type where you can perform some operation, we call them as abstract, is because the implementation for array changes from language to language. And we don't just have array, right? So let's say if you want to store a bunch of values, we can use list, we can use set, queue. Now when you talk about a queue here, let's say. Now inside queue, we have one more option for that, which is stack. They follow different concepts. So let's say if you want to add an element in the queue, which follows last in first out, which means you have to insert from the end and you will get it from the first. Of course, you can reverse it. You can insert from the start and you can take it from the end. The thing is, you will insert from one end and you will remove from the other end. So that is first in, first out. In stack, it is reverse. You do last in, first out. Example, let's say, to give an example, let's say for queue, we can say a queue which you follow, right? Example, if you want to buy a coffee from a cafe shop, of course, there's a queue there. You have to stand in a queue, and then when your number comes, you will get the coffee. So basically the first person who went there first will be getting the coffee first, right? In terms of stack, it is different. So when you keep multiple books, the first book which you can take out is the last book which you have kept there, right? Which is last in, first out. That is your stack. Now, we have different way of implementing in different languages. The concept remains same, right? So when you have a concept and the associated operations to it, and of course with data, which we call them as abstract data type. We also have map, but we'll talk about those things later. At this point, the point to remember is we can create our own types, and which is a concept. And if you want to have data inside that, and also you want to specify what operations you can perform, that is your abstract data type. Of course, in the subsequent videos, we'll talk about how do you create them, how do you work with them, and it will be fun. So see you in the upcoming videos, everyone. Bye-bye.